We're going to begin this section talking about the reciprocal identities. But first let's review what a reciprocal is. Remember, you learned that the reciprocal of a number, let's say the reciprocal of 1/3, would be simply that number flipped, or in other words, 3 over 1. So we're going to apply that knowledge of reciprocals to trig functions here. Each of the 6 trig functions has a corresponding reciprocal value. So in other words, the sine of theta would be 1 over the cosecant of theta. Cosine of theta is 1 over secant theta. Tangent of theta is 1 over cotangent theta. So each of those 6 trig functions we've been discussing so far have a related reciprocal value. Something to think about: the reciprocal of our trig function is going to give us the inverse of the ratio. And we'll discuss that a little bit further in this next example. So the reciprocal of the function gives us a number back, but the inverse of my function gives me the angle measurement back. So here one way, the reciprocal is going to give me a number, okay, is going to give me a value, but the inverse is going to give me an angle measurement. So those things are commonly confused, and they'll become clearer as we move through the semester. One other thing I want to caution you on is, or I want you to remember, is that if I'm talking about a reciprocal identity, here I've written down the sine of theta is equal to 1 over the cosecant of theta. I can rewrite this single identity 2 other ways. So this is one way, or 3 other ways. Another way to rewrite that is to say, okay, well, the cosecant of theta would be equal to 1 over the sine of theta. And finally, if I were to simply multiply both sides, let's look at this one right here. If I were to multiply both sides of this equation by the sine of theta, I would end up with the sine of theta cosecant of theta is equal to 1. So here I have a single identity relationship that can be represented 3 different ways. So now let's move into our first example that we want to cover. This first example asks us to find the function value given the relationship here and make sure that you write it with a rationalized denominator. So in other words, we shouldn't be giving back any decimal values, or in other words, not using our calculator yet. So this first one, the tangent of theta, I want to know what the tangent of theta is if I'm given that the cotangent of theta is equal to 4. Cotangent and tangent are related in their through the reciprocal identity that the tangent of theta is equal to 1 over the cotangent of theta. Therefore, the tangent of theta would be equal to 1 over the cotangent of theta, which is just 4. So that's the reduced value. We understand then that if the cotangent of theta is 4, then the tangent of theta would be 1/4. Now let's look at another example. This one is asking to find the secant of theta given the cosine of theta is -2 over the square root of 20. So the reciprocal identity for these 2 trig functions says that the secant of theta is 1 over the cosine of theta. If I know that the cosine of theta is -2 over the square root of 20, then I'm going to replace that down here in the denominator. So I have 1 over -2 over the square root of 20. So this is really just a complex fraction. If I take a complex fraction like this and simplify it, we're going to make it look kind of like this. I know that this fraction bar right here technically means division. So if I'm going to take 1 divided by the denominator, that means I multiply by the reciprocal, which would be -20, negative square roots of 20 over 2. And therefore, that answer looks like negative square root, I'll get it right, negative square root of 20 over 2. This answer is not simplified in its entirety because I can actually simplify further the square root of 20. The square root of 20 would reduce to be -2 2 square roots of 5 all over 2. And since I have this number out here outside of the radical and this denominator here, those are both 2's, I can then reduce this even further so that this looks like negative square roots of 5. That's your final answer right there. The last one we want to look at is asking for the relationship, or in other words, I want to find out what the sine of theta is given the cosecant of this long value here. I know that sine and cosecant are reciprocals of each other, so therefore I have that the sine of theta is 1 over the cosecant of theta. The cosecant of theta is this big long decimal value here. That's going to clue me in to know that I'm looking for, I'm going to be using my calculator. But in order to do this on your calculator, I'm going to rewrite it so that I put it into the calculator in the correct order. I'm technically looking for 1 over the cosecant of theta, which is 1.42716321. That's going to give me the sine of theta. This value right here is what I want to therefore put into my calculator. So let me bring my calculator up, and I'll just put that fraction in. 1 divided by 1.427163321, and when I hit enter, I'm going to take the decimal value that I'm given there, and I'm going to say that this is 0.7006971. And that's how I would do it on my calculator. First, I rewrite. I want to be sure you understand. I'm going to rewrite the reciprocal in this way right here, and then let the calculator do the division on that. Do not, I repeat, do not try to find, do not use the reciprocal button on your calculator. Let me pull that up. Do not use the reciprocal button right here, which is really the inverse button. This is not going to give you the correct answer. You cannot take the inverse and get this value using your calculator, or you cannot incorrectly assume that this value that this function here is going to give you the reciprocal, because in fact that button gives you the inverse. And again, those are two different things when we talk trig.